You have done it on every flight you have ever taken, New York, Tokyo, London, it does not matter, regional jet or double-decker Airbus A380. Oh, it does not matter. You always walk onto the plane from the left. You never questioned it, neither did anyone around you. But the reason reaches back over 1,000 years to sailors who had never seen an airplane and a problem that had nothing to do with aviation. The detail you never noticed. Think about the last time you flew. You checked in, navigated the terminal, waited at the gate, and when the boarding call came, you walked down the jet bridge and stepped onto the aircraft. The door was on your left as you faced the plane. It is always on your left as you face the plane. This happens at every commercial airport in the world. It happens regardless of which airline is operating the flight, regardless of which aircraft type is being used, regardless of which country the airport is in. The left side boarding convention is one of the most universally consistent practices in global commercial aviation, applied billions of times per year across hundreds of thousands of daily flights, and the overwhelming majority of the passengers participating in it have never once stopped to ask why. The answer has two parts. The first is historical, reaching back to a time before aviation existed. The second is practical, rooted in the specific operational logistics of a modern airport ramp. Understanding both requires starting not at an airport gate, but at a harbor, specifically at the harbor of a Viking or early medieval seafaring civilization, and looking at a problem that right-handed sailors had with steering their boats. Starboard, port, and the right-handed sailor. Before the invention of the stern rudder in medieval Europe, ships were steered by a large, heavy oar, essentially an oversized paddle mounted on one side of the vessel near the stern. This steering oar required constant physical management by the helmsman, who held and worked it throughout the voyage. The vast majority of sailors, like the vast majority of humans, were right-handed. A right-handed helmsman controlling a steering oar would naturally position that oar on the right side of the vessel, where his stronger arm could manage it most effectively. This was not a formal decision or a naval regulation. It was the natural ergonomic outcome of thousands of individual sailors on thousands of individual vessels, all solving the same physical problem the same way. Over time, the right side of a ship became universally associated with steering. In Old English, the word for steer was steor, and the word for side or board was board. The steering side of the ship became the steerboard, a compound word that evolved through centuries of linguistic change into the modern English word starboard, still used today to mean the right side of any vessel. Now consider the docking problem this created. A ship with a large wooden steering oar extending from its right side cannot safely dock against a pier on that same right side. The oar would be crushed between the hull and the pier structure, damaging or destroying the equipment the crew depended on for navigation. The practical solution was obvious. Dock on the left side, where there was no protruding oar to protect. The left side of a ship became the side that faced the port, the dock, the pier, the loading facility. Through this repeated association, the left side acquired its own name. It became known simply as the port side, the side that faces the port. This terminology, established through practical necessity in the harbors of medieval Europe and Scandinavia, is still the universal convention in maritime navigation today. Port means left, starboard means right. Every sailor and every naval officer in the world still uses these terms, derived from the right-handedness of ancient helmsmen and the inconvenient geometry of their steering equipment. When aircraft became ships of the sky, when powered flight became practical in the early 20th century and the first commercial aviation operations began to develop through the 1910s and 20s, the people building and operating aircraft faced a question that seems simple in retrospect, but was genuinely open at the time. What conventions should govern the operation of these new flying machines? The answer, reached not through formal deliberation, but through the natural inclinations of the people involved, was to borrow extensively from the maritime tradition. This was not surprising. The earliest aviation pioneers and the first generation of commercial airline operators came from a world in which ships were the dominant form of long-distance transportation. The vocabulary, the organizational structures, and the operational conventions of maritime navigation were the most developed and widely understood framework available for managing complex vehicles carrying passengers over long distances. Aviation adopted maritime language wholesale. Commercial aircraft were commanded by captains. The second in command was the first officer. Airlines organized their aircraft into fleets. The right side of an aircraft was its starboard side. The left side was its port side. These terms appear in aviation regulations, aircraft manuals, and operational documentation to this day. And along with the terminology came the operational convention that port side, the left side, was the side from which passengers embarked and disembarked. Just as ships had loaded and unloaded passengers and cargo from their port side, with the starboard side reserved for the steering mechanism and later for various operational equipment, early aircraft operations naturally positioned passenger access on the left. This convention solidified through the 1920s and 30s as commercial aviation grew and airport infrastructure began to develop around it. Jet bridges, the enclosed walkways connecting terminal buildings to aircraft doors, were designed to interface with left-side aircraft doors as a matter of standard practice. Gate layouts were configured accordingly. Ground handling procedures were developed with left-side passenger access as the baseline assumption. By the time commercial aviation reached its post-war expansion phase in the 1950s, the left-side boarding convention was so deeply embedded in airport infrastructure, aircraft design, and operational procedure that it had become effectively immovable. The modern logic, why the right side is a work zone. The historical origin explains why left-side boarding started. The practical logistics of modern airport operations explain why it has never been seriously challenged and why the convention has become more rather than less entrenched as aviation has grown. Stand at a terminal window and watch the activity around an aircraft during a typical turnaround, the period between one flight landing and the next departing. What you will see is a remarkably coordinated but genuinely busy operational environment involving multiple vehicles and work crews operating simultaneously in a confined space. The refueling truck connects to fuel ports typically located under the wings or on the starboard side of the aircraft. Baggage handlers work the cargo holds, which are accessed from both sides, but with much of the heavy equipment, e.g. conveyor loaders, baggage carts, bulk cargo vehicles, positioned on the starboard side. Catering trucks extend their scissor lifts to the galley doors, which on most commercial aircraft types are on the right side of the fuselage. Ground power units connecting electrical supply to the aircraft during engine-off operations are positioned on the right. Pushback tractors attach to the nose gear from the front, but their operating space intersects primarily with the starboard side. The right side of a commercial aircraft during a turnaround is a high-density, actively hazardous work environment involving heavy vehicles, powered machinery, fuel under pressure, and workers moving quickly under time pressure. The consequence of introducing pedestrian passenger traffic, including elderly passengers, families with young children, and passengers unfamiliar with airport ramp environments, into this work zone would be serious and predictable. Left-side boarding is not just historical inertia, it is a functional separation of incompatible activities. Passengers move on the left, protected from the machinery on the right by the width of the aircraft fuselage. The two streams of activity, human and mechanical, proceed simultaneously without conflict in parallel on opposite sides of the aircraft. This separation reduces the turnaround time, reduces the accident risk, and allows the complex ballet of a modern aircraft turnaround to proceed with the efficiency that makes the economics of commercial aviation viable. The captain's seat and the final practical detail. There is one additional practical factor that reinforces left-side boarding, and it is found in the cockpit. By universal convention in commercial aviation, the captain, the pilot in command, occupies the left seat of the flight deck. The first officer sits in the right seat. This seating arrangement is itself a historical convention with maritime roots, but it has been standardized across commercial aviation for so long that it is simply the way cockpits are designed and the way pilots are trained. The practical consequence for boarding is subtle but real. When an aircraft is taxiing to its gate or being pushed into position at a jet bridge, the captain in the left seat has a direct sight line along the left side of the aircraft. Judging the alignment between the aircraft's left side doors and the jet bridge connection point is more natural and more accurate from the left seat than from the right. The captain can directly observe the gap closing between the door sill and the jet bridge canopy, can make small corrections to the aircraft's position with direct visual reference, and can verify the connection alignment without relying entirely on ground crew guidance. This visibility advantage reinforces the operational preference for left-side docking at jet bridges, which reinforces left-side boarding, which reinforces the design of airport infrastructure around left-side access. Each practical detail supports the others, and all of them point back to the same side, left, port. the side without the steering oar, the side that faced the harbor, the side that became the universal convention 1,000 years before the first aircraft ever flew. Conclusion. Every time you board a commercial flight, every single time, at every airport, on every airline, you are participating in a convention that began with right-handed Viking sailors protecting a wooden steering oar from a harbor pier. The maritime world gave aviation its language and its organizational structure. It gave aircraft their captains and their fleets. It gave the right side of every plane its name, Starboard, and it gave the left side its defining characteristic, the side that faces the port, the side where people come and go. Modern airport logistics reinforced what history established. The right side became the work zone. The left side became the passenger side. Airport infrastructure was built around it. Aircraft were designed with their primary passenger doors on the left. Jet bridges were configured to connect there. Ground handling procedures were organized to keep those two worlds, the mechanical and the human, separated by the width of the fuselage. The captain's left seat view completed the picture, giving the pilot in command direct visual confirmation of the alignment that makes safe boarding possible. History, logistics, and cockpit geometry, three independent reasons 1,000 years apart in origin, all pointing to the same side. The next time you step through that left side door and find your seat, you are not just boarding a flight. You are stepping into one of the longest unbroken operational traditions in the history of human transportation. It started on the water, it moved to the sky, and it has been pointing left ever since.